Hello students, this is the video companion for Introduction to Three-Dimensional Shapes. So in this we're going to name these shapes. We're going to use this word bank. In this shape, this is a rectangular prism. It is a rectangular prism. It has two bases, and as the name states, the bases are rectangles. The next shape, okay, the next shape based on what you saw the first shape, what do you think this shape might be? I'm going to cross out rectangular prism. Like the first shape, it has two bases, so it's a prism. But it has two bases, and the shape of the base is a triangle. So if we look, it is a, not triangular pyramid, triangular prism. Triangular prism. Okay. Here we have a pyramid, traditional, what we think of as a pyramid, like in Egypt. It has one base. The shape of the base is a rectangle. Now on this, are all the triangles the same? Well, we'll know whether they are the same or not by looking at the base. If the base is not square, then the triangles will be different. So the answer to that is no. So this is a rectangular pyramid. Rectangular pyramid. Okay. Moving over. Here we have another pyramid similar to the last one, except as we notice we have the marks that indicate that all the sides are congruent. So that makes the base, it has one base here, and since they are all congruent, we know that this is a square. Yes, they are all congruent, so it is a square pyramid. Square pyramid. Okay, following up. Now these are a little bit tricky. Sometimes these nets are laid out. These are called the nets. They're what the shape looks like unfolded. So in this case, we're looking at another pyramid where the one base is in the shape of a triangle, and therefore it is a triangular pyramid. Triangular pyramid. Now, one thing to know, one thing to pay attention to on these is, sometimes the sides, the faces of the pyramid are not the same as the base, and so you have to pay close attention. To the base. It is unique, or could be unique. If there's one unique triangle, that's the base. Okay, last one here. So here we have what's called a cylinder. Now, a cylinder you might think of this as like a round prism, but its name is actually cylinder. And how many bases does it have? Well, it has two, like a prism. And its shapes are circles. Shapes are circles. And that's the identification portion of this activity. Turn it over to the back. All right, let's talk about surface area. Surface area. Now we're going to define surface. Now what is the surface of something? If we say somebody's superficial, we're talking about the outside, right? Things that are on the surface are on the outside. So to define the surface more than outside in this, we're talking about the outside of a 3D object. Talking about the outside of a 3D object. And what else can we say about surface? It is two-dimensional. Measured in square units. Now I only say that because we're going to get into volume, which is three-dimensional. Now the objects are three-dimensional that we're measuring, but we're only measuring the surface, so we're talking about the two-dimensional space. So that's what we mean by area, as in contrast to volume. Area is the 2D space. The shapes, I'm going to use the word cover. I'm going to use the word shape. They cover, as opposed to the amount of space something takes up. It's volume. So just be careful as you go forward. Have a very clear distinction between surface and between area and volume. So when we talk about surface area, so we're talking about the total, all sides. Surface area is all sides of the 3D shape or combined area. I'm going to use that word area again. So the example would be, think of an example of like covering something. When do you cover something? Like gift wrap. Gift wrap is a good idea of surface area. So maybe it's the amount of material, say, that it takes to make up, like, you know, if like a ball, or the area of the Rubik's Cube, not the volume of the Rubik's Cube. So gift wrap might be one. How much it needs. Also might be the surface area might be, oh, paint. How much paint it takes to paint something. Takes to cover something. So it could be a shed, a house, something like that, where it's made up of different things. Okay, moving on. The surface area of prism is the sum. Now here we get into the actual definitions, the book definitions. So you have a 3D object and the net. The prism is the sum of the areas of its faces. So we have all of these are faces. You can determine the surface area by determining the area of the prism's net. So if we unfold this box and we look at each unique rectangle and find the area of each and just add those up, we'll know its surface area. So looking at this example below, we'll calculate the surface area of a shape. Simply calculate the area of each side, then add them all together. So the area of this is 15 times 10, that's 150. The area of this is 10 times 10, that's 100. The area of this is 10 times 10, it's 100. This is 15 times 10, so there's another 150. Here's another 150, and here's another 150. So if we add all the 150s together, 150, 150, 150, that's 4 of those. That's 600. And then we have the two bases, the two ends, 200. So the total surface area is 800. All right, continuing. So here's some practice problems on the next page. We'll check our work so far on key number 1. Now let's just keep going. I'll be your key. How about that? If you have any questions, please see us. All right, the name of this shape. So what we have is some rectangles, right? Several rectangles, and we have 6 sides and 2 bases. It is a rectangular, what? Rectangular, the word is prism. Okay, so to find the total surface area of this, it helps if we make our own type of net or break it out. So we have 2 sides that are 6 by 4. So let's go 4 and 6. 4 and 6, okay? So we got those ends. Now we have a side that's 2 ends that are 7 by 4. 7 by 4, 7 by 4. And now we have the top and the bottom, which are both 7 by 6 and 7 by 6. So yes, this is a broken up net, but this helps me break out. I have all six sides. So 7 times 6 is 42, 42, okay, 28, 28, 24, and 24. So if I just add all these up, I will have the total surface area. So 24 plus 24 is 48. 28 plus 28 is 56. 56. 42 plus 42 is 84. So now my total surface area is 48 plus 56 plus 84. Let me come over here and do that math. 84, 56, 48. 6 and 4 is 10, plus 8 is 18. 9 plus 5 is 14, plus 4 is 18. So we have 188 square inches. Remember, we're not finding volume, we're finding the surface area. Okay, I'm going to pause the video. You pause the video and you work out the surface area for this problem. When you click it, I will count down from 5 and reveal the answer. Okay, we're back in 5, 4, 3, 2, 1. Okay, here is the answer to the last problem. It is a rectangular prism and it has 108 square feet. Okay, now we're going to talk about surface area of triangular prisms. Much like with the rectangular prisms, we're going to break it up into the individual shapes. So if we look at this example, we're going to total up all these different faces and bases. We'll use this big space up here at the top. So let's look at what we have. We have the 3 faces, and they're all 20 high. And then the base length, the little b base length, are these. So you have an 8, you have a 17, and you have a 15. So you can find the area of each of these individually. 20 times 15 is 300. Okay, that's like 15 times 2 with a 0. 8 times 20 is 8 times 2 with a 0, so I'm going to turn it right like that, 160. And then we have 20 times 17, which would be like 17 times 2 is 34, with a 0, that's 340. And then we have the 2 triangles, so we'll put those here because they're 15 by 8. 15 by 8, and we have 2 of those. Okay, so you could draw the other one down here. So anyway, this is one way of doing it. How you organize it is whatever works for you. Now, so if we add up 340, 160, we get 500. Plus another 300 is 800. So we've added up these 3 things. Now we're going to do our 2 triangles. Now it's important to remember the triangle formula. The triangle that we're looking at is 8 by 15, and the area is base times height divided by 2. So we have 15 times 8 divided by 2. 15 times 8 is 120 divided by 2. So the area of each triangle is 60. 120 divided by 2 is 60. But we've got 2 of these. We had 2 bases, so we're back to 120. So 800 plus 120 is 920. 800 plus 120 is 920. So the area of the triangular prism is 120. So just to recap, we did all three sides, found the area of each face, and then we did our two bases, which are triangles. So we really have to remember to do our divided by 2 because they're triangles. Okay, I'm going to pause the video and I'm going to let you work out problem number 1, and then when you come back we'll show the answer. Okay, so coming back, the answer to the first problem on the practice was, did you get 108? 108. So your three faces, they're all 8 high. So you have 8, 8, and 8. 8 times 3 is 24, 8 times 5 is 40, and 8 times 4 is 32. So if you add all that up, it's 96. Now I'll show you a cheat. You can hack this a little bit. If you add up all these, you get 12, right? And 12 times 8 is, guess what? 96. Once we had our 96, we added it to the area of our two triangles, and we got 12, and that made it 108. Okay, we're going to pause the video again and give you a chance to do the second practice problem. When you come back, I'll show you the answer. Okay, we're back on the second practice problem. It was a triangular prism. We could break it up into three faces. They're all 11 high, and they have base lengths of 8, 15, and 17. And you can find them individually, like 165, 188, and 88. 11 times 17 is 187 and 88. That comes out to 440, sorry. And if we add our 440 to our triangles, which are 8 by 15, there's 2 of them, you get 120. So the total is 560. 560. And that goes through the introduction to surface area of triangular prisms, surface area of rectangular prisms, and explaining the characteristics of all the different shapes. Thanks for watching.